alaikum, sir. I am Sifat Akhtari and my teammate is Juhai Rahnab Jihan. Today we will present our mini project for CSE207 titled Banking Transaction Manager with Fraud Detection. This project was completed under the guidance of our instructor, Dr. Nafis Sadiq. Introduction to the Banking Transaction Manager. Our project focuses on designing a banking transaction manager equipped with a fraud detection mechanism. As seen on this slide, the system uses fundamental data structures like BST, stack, and queue to simulate real banking operation. It supports core features such as account creation, deposit, withdrawal, undo functionality, and threshold-based fraud detection. System overview. Core banking operations. This slide breaks down the core operations of our system. We have four main functional areas. Account management. Creating accounts, depositing, and withdrawing. Transaction control. The system can undo the most recent transaction. Fraud monitoring. Suspicious transactions are automatically flagged. Reporting. Users can view all accounts and fraud alerts in a structured way. Together, these features simulate essential banking activities. Fundamental data structure. Our system is powered by 3K data structure. BST stores accounting using account numbers as keys and supports efficient searching and sorted output. Stack stores transaction history and enable the undo feature. Queue holds suspicious transaction flagged by the fraud detection module. Understanding this structure helps explain how the system behaves internally. System architecture data flow. This slide illustrates the complete data flow of our system. All accounts are sorted in the BST. Whenever a transaction occurs, a record is pushed onto the stack to allow undo operations. If a transaction amount exceeds the fraud threshold, it is simultaneously added to the fraud queue for review. This ensures proper tracking of both normal and suspicious activities. Now my next teammate Juhair will complete the next part.
Sir, my name is Joanne Abjian and I'm going to continue from this part. Our system is divided into modular components. First of all, add account, which inserts a validated unique account into the BST. Then deposit and withdraw, which updates balances and locks transactions for undo. Then undo last transaction, which uses stack to reverse the most recent operation. These modules ensure proper account management and correction of user mistakes. Moving on, fraud detection and reporting modules. Fraud detection is implemented using a configurable threshold which defaults to 1 lakh. Any transaction equal to or above this threshold is automatically flagged and placed into the fraud queue. Reporting includes showing all accounts in sorted order using BSD traversal and showing the fraud queue in FIFO order. These modules provide transparency and monitoring capability. Moving on, here we summarize the time complexity of our main operations. BSD operations like search and insert are big O of log n on average, though can become big O of n in the worst case. Stack operations such as push and pop are O of 1, which makes undo very fast. QE operations in QE and DQE are also O of 1. This ensures our whole system remains efficient even as data grows. In this slide, it shows an actual sample output of our program. A withdrawal of 150,000 triggers the fraud detection mechanism because it exceeds the threshold. As shown here, the system both processes the transaction and flags it as suspicious. The fraud records section then displays detailed information about the flagged transactions. So to conclude, our system fulfills all requirements of the mini project. It successfully implements account management through a BST, undo functionality using a stack, and fraud monitoring using a QE. The system is interactive, stable, and demonstrates key data structure concepts in a practical context. Thank you for viewing our project.